Everyone, I'm Rosa Marita Panuba from BSEE 1A. So in this topic, let's talking about work and kinetic energy. For checking your understanding 7.3, page 335, problem set number 1, find the work done by the same force in example 7.4 over a cubic path, y which equals to 0.25 meter to the raised power of negative 2x cubed between some points a which equals to 0 and 0 and b 2 meter and 2 meter. Given below y which equals to 0.25 meter to the raised power of negative 2x cubed. For the force, 5 newtons per meter plus 10 newtons per meter for A, 0 and 0 for B, 2 meter and 2 meter. Using the equation of y and dy, or using the equation to express y and dy in terms of x and dx, y in terms of x. So which y is y which equals to 0.25 meter to the raised power of negative 2 x cubed. For dy, 0.25 meter to the raised power of negative 2x x squared dx. For the formula for the calculating the infinite decimal elements of work, we have the formula of dw which equals fx dx plus fy dy equals 5 newtons per meter plus 10 newtons per meter. Mauni siya to ang Fx ang 5 newtons per meter and for Fy 10 newtons per meter. Equals 5 newtons per meter 0.25 meter to the raised power of negative 2x cubed dx plus 10 newtons per meter. 0.25 meter to the raised power of negative 2x x squared rather minus x dx. So that 3 times 0.25 meter to the raised power of negative 2x squared, man siya to ang answer nga 7.5 newtons per meter cube. X to the negative power of negative 3 dx. So that makakuha tag answer nga 8.75 newtons per meter cube x cube dx. So that the value of work integral W or newtons per meter cube x cube dx. So 8.75 newtons per meter cube x to the 4th power over 4. So ato rin siyang i-multiply so that our final answer is 35 joules. So this is the problem set number 2. Check your understanding 7.4, page 337. The spring is compressed 6 cm from equilibrium length for A. Thus, the spring force the positive or negative work. For B, what is the magnitude? For letter A, my answer is negative since the force acting or it is opposite. So compressed by compressing which is opposite direction. So broken line, so nakakita mo na ng broken line, man siya tong our equilibrium length. Then for the left side which is the negative, and for the right side which is our positive. For B, magnitude remains at 0.54 joules. It's because it said and the people of 7.5 that it needs 0.54 joules of work to stretch 6 cm from equilibrium stretching. It's just an opposite of compressing, to therefore the work is a negative, but we are talking about a magnitude that can never be negative. So that the length of a spring is negative, the work is always be positive. For stretch, kung ma-stretch ang spring, which is the spring force is greater than 0. For the compress, so kung ma-compress ang string, so the forces are lesser than 0. Check your understanding 7.6, page 340. So problem set number 3. You're rowing a boat parallel to the banks of a river. Your kinetic energy relative to the banks is less than your kinetic energy to the water, or no rowing with or against the current? So my answer is it is against the current, because in the first place, the kinetic energy of a person rowing relative to the banks is lesser than to the kinetic energy of a person rowing in the opposite direction of the current. If we take a value on it, if you're rowing with the current, both velocity will be added and your kinetic energy will become higher. Whereas, if you row against the current, the velocity of the water current is subtracted to the velocity of the boat, so that the kinetic energy will be less. So, kinetic energy person relative to the banks and kinetic energy person relative to the water current. For check your understanding 7.7, suppose the radius of the loop in example 7.9 is 15 centimeter and the toy car starts from rest at the height of 45 centimeter above the bottom. What is speed at the top of the loop? So that our velocity 1, which equals to 0, so the given below y1, or the y sub 1, which equals to 0.45 centimeter, for y sub 2, which equals to 0.15 meter, and y2, which equals to 0.30 meter. For work energy theorem, so negative mass gravity, or the mg, y2 or minus y sub 1, which equals to 1/2 meter mass velocity to the rest power of squared, and then negative mg, or the mass gravity, or the 2 radius y1, which equals to y1/2 mv2 squared. So mv2 squared over m. So ato ani siyang i-cancelled out. So that negative 2 mg, or the mass gravity 2r, negative y1 over mass, then square root of v2 squared, which equals to negative square root of negative 2 gravity rather, 2r, which equals to 2r minus y sub 1. So v2 equals negative 2 gravity, 2 radius minus y1, and v2, which equals to square root of negative 2, 9.8 meter per second squared, 0.30 meter minus 45 meter. So the velocity 2, which equals to square root of 20 meter per second squared times 0 minus 0.15 meter. For velocity 2, which equals to 3 square root of 3 meter squared, squared meter per second squared. Then the final answer is square root of 3 meter per second. So that our speed of the top of the loop, which equals to square root of 3 meter per second. That would be all. Thank you.